Okay, today's video is a wrap-up project for the RZR Mux. Big series of videos on how to design a product, an enclosure, software design, the whole 9 yards for this particular application. Was an automotive application for a RZR, Polaris RZR UTV, mine in particular. Here's a shot of the KiCad design. I used KiCad to actually develop the board and sent that off to Oshpark, and Oshpark sent me a board back, and I went through, I think, 3 iterations. You can kind of see here on the desk, this is actually me doing a load test on a development board, and that actually came from the manufacturer. 2 big boards that didn't have the integration that the final product had. I also did a software development section of this, kind of showing how to do STM8 development. Very inexpensive processor. I think they're 70 cents or so on Mauser or DigiKey. And this was the automotive version, so this had a Canbus transceiver. And what this, the intent of this was, is this software actually will read 4 inputs and control 4 outputs. And the big key thing is it's actually pulling messages off of the Canbus and doing things with those outputs. 2 of the big things were the reverse light. So when you put this gear selector in reverse, it would turn on the reverse lights, and when you put the put it in drive and you're going forward at low speed, it would look at the speed and turn on the rock lights. Here's just a little bit more footage of the schematic and the actual load test itself. So in the design process, this was the initial stage, basically buying some developmental boards, testing out code, theory, and parts, and doing a bit of testing before doing a lot of design. And this, a lot of people ask, this is about I don't know, I did this within a week. So basically ordering parts, getting them, doing the design based off of what I found with the developmental boards, and then getting boards back from Oshpark. And I think I went through 3 iterations of boards from Oshpark. So basically, I think the very first one may have been almost an entire failure. I did get something working, but there were a couple of issues that I wanted. Actually ended up changing out some parts. But here's just basically doing testing, and you can kind of see here by the lab bench some of this equipment that I got during this time. I did videos on some of that, just to kind of give you an idea of what it takes to actually do one of these. Really, all you really need to have is an oscilloscope and a good voltmeter. And I also went through like Metcal. That's one thing I'll say: if you invest money in anything, the soldering station seems to be where I gained the most productivity over what I had before. This is actually the reflow oven that I built to do it yourself. I think I bought the control kit off of eBay, bought an oven at Walmart, and basically rewired the oven to work as a reflow oven. It works 100% of the time with leaded solder. It does a really nice job with the reflow. You can see the joints there, and the really small parts. No tombstoning or anything like that. Nice even heat and reflow process. I still use that all the time on almost any of the projects that I'm doing at home. And after this process, the board basically gets the wires soldered on by hand and gets a conformal coating. And the conformal coating is actually what provides the dirt and water protection for the board. Here's an early board that I did during my VMC swap out, when I did the small time that I didn't have a mill. My brother graciously CNC routed these PVC enclosures so that I could actually protect the board mechanically from anything smacking into it on the RZR. The aluminum enclosure will be coming up here in just a bit, but this is actually on my RZR. This is one of the first tests, and basically this is got 12 volt power. It's got 4 inputs, 4 outputs, and it also connects to the Canbus connector. And here in a second, you're going to see it actually switch an 18 amp load, which is the lot bar. No relays. This is all solid state. And we're also measuring current, so if there's a problem we can detect it and turn off and reset without having to replace a fuse. But that's it coming on and off based off of a switch that I have on the dash. This is after I got the mill, and this is kind of when I started going into the final stage of production, which is wrapping up with the final version. That's a Balix forming tap. That basically displaces metal to tap after you drilled an undersized hole versus cutting, which was a really cool thing, and ended up with a really nice thread in the enclosure. I really like those for aluminum. The mill, still a great process. It has improved my workflow greatly with product development, having everything here. Again, this is my own personal stuff, so being able to do a board design or what have you and run down to the shop and actually run an enclosure is really nice, especially with RF projects. And this machine's pretty much probably a little oversized and a little overbuilt for my needs, but I've really enjoyed having it down in the shop. This is actually milling one out. This is one of the first ones. Later I went and did a fixture so that I could do 8 parts, which would be 4 tops and 4 bottoms, so a total of 4 enclosures, but 8 parts, and it would do them really quick. You could basically set everything up, set it in the machine, hit the go button, and after the cycle ended, you would have just a facing operation to eliminate the spare material. So I could produce these pretty quick. I really like enclosures done in 6061 or 7075. It's really nice on tooling, it looks nice, and it machines really well. I think everybody says everybody's a hero in aluminum, but here is one built. This is one of the first test fits on a assembled board. So you can kind of see how that all fits together. Basically it sits down in the void, and it's a clamshell design, so you would actually have another part that went over the top of the board. All of the water protection is on the conformal coating. You can kind of see it here in this video. That board's really shiny, and that's a conformal coating on top of the board. Anyway, I just want to do a quick wrap-up video. If you haven't checked out the other videos, please do so. I've got everything from this design process to getting the VMC to 3-phase power. If you've ever wanted to get into machining, especially if you're looking at machining plus electronic and software design together, it's a pretty good series, and I appreciate everyone's subscriptions and likes, and we'll see you on the next one. I've really enjoyed this project. Thanks.